Hey, Frank.
Hey, how's it going? Can you hear me?
Good. How are you?
What's going on, Frank?
Good. Hey, Sid. Yeah.
All right. Let's get my screen shared here. Just want to test this out, make sure it's working correctly.
It says top broadcast. Are you already broadcasting?
Yep.
All right, so everybody can.
Yep. So I start
see this.
to make sure that we're good to go. So let me do this. Which is good. All right. So this one. Which screen can you see right now?
I see the title screen.
Can you see the notes as well?
No, I don't see any notes.
Perfect. All right, Frank, take it away.
Okay. This is the Intelligent Pavement Management Planning session here, and we're here with Tito Sanchez from Beta Group and Joe McGuire, and also Stu Frick from Robotics that we work with a lot to deliver pavement management solutions to our clients using robotics objective data-driven technology. So if you guys want to get started, go ahead.
Sure, absolutely. Thank you. So hi, and welcome to Intelligent Pavement Management Planning. As Frank had mentioned, I'm Tito Sanchez, the GIS Project Manager for Beta Group. I'm accompanied today by Joe McGuire, who's a GIS analyst here at Beta. And we also have Stu Frick, who is the Partner Success Lead from Robotics. Now, over the past few years, we have partnered with Robotics to offer the latest in pavement management data collection technologies. Today, we'll be discussing not only some of the best practices of properly maintaining your roadway network, but we will also show you some innovative ways to collect pavement data in the field. We will also showcase how we utilize the latest in GIS technology to display pavement data using intuitive and user-friendly web-based solutions. First, a little about us. Beta Group Inc. was established in 1982. We're an employee-owned, multidisciplinary, full-service engineering firm. Our main office is located in Lincoln, Rhode Island, and we have 5 additional offices throughout New England. Our integrated approach to projects means that our team works together to provide smart solutions for our clients' needs, improving the communities where we live and work. The focus of our presentation today is on Beta GIS and asset management discipline, which includes pavement management planning. We have also partnered with Robotics, that I had mentioned before, to carry out our roadway assessments. Our extensive experience with public works officials have given us a vast understanding of what a successful pavement management program requires. By leveraging data to make well-informed decisions, we develop programs that are well received by community stakeholders and the public end users. We strive to offer cost-effective, customizable solutions that help our clients analyze and manage their roadway network in the most efficient manner possible. We have inspected over 1,600 miles of roadway throughout 11 communities in Rhode Island, including the biggest roadway networks in the state, Warwick, Cranston, and Smithfield, where we've done comprehensive pavement management programs. Actually, Smithfield was our first robotics client back in 2018. Up next, Stu Frick will give his introduction to robotics and the services that they offer.
Hello, and thank you, Tito. So what I'm going to be going over is how the robotics technology works and how utilizing newer technologies can assist in pavement management planning and GIS asset management practices like Beta does. So essentially what I'm going to be going over is the data collection and initial analysis practices and technology that we utilize to be able to provide Beta with the data that they need to conduct the further analysis on the streets and make the recommendations that the communities need that they work with. To give a bit of a preface to Redbotics, so we're a technology company that originated from Pittsburgh, but work nationwide and internationally. We worked with over 250 communities across the globe in 14 different countries and in 34 separate US states, with a lot of our work being done in the New England area, particularly in Massachusetts and Rhode Island. So to put it simply, the way that Redbotics works and the way that we're kind of changing the landscape of asset recording and data processing within the world of pavement management is that we utilize different types of technology and equipment to bring in the data that our partners need to use. So the way that we do that is we record the imagery of roads themselves with a smartphone that is then processed using artificial intelligence models to produce conditional ratings of the roads themselves. So we kind of offer ourselves as a counterpoint to traditional visual and manual inspections that can take a very long time and require a lot of in-field work, whereas utilizing Redbotics, you're able to do so a lot faster and do more work from the office, making plans and executing the plans for pavement preservation rather than spending a lot of time in the field analyzing the roads themselves. What we're looking at here is a quick overview of the conditional ratings that Redbotics outputs as part of our data analysis. So what we've strived to do is kind of break down into slightly simpler measures the outputs of the data of the road quality themselves. So we go on a 1 to 5 scale, 1 being the best, 5 being the worst. And then again, all of those ratings are produced using artificial intelligence models that are able to scan images of roadways and determine what the quality of the pavement is itself.
Great, thanks, Stu. So what is the importance of pavement management planning and how does it benefit a community? Well, allocating funds is a challenge when your budget won't cover all of the work to be done. However, by taking a proactive approach, you can make better funding decisions and get a higher return on your infrastructure investment. Traditionally, municipalities allow the structural condition of a road segment to deteriorate to a fair or poor condition before taking action to rehabilitate or totally reconstruct the road. The logic behind this process was to achieve the most useful life out of a road, typically 15 to 20 years for an asphalt segment, and thus maximizing the required capital investment. There are 3 problems with this reactive approach to road maintenance. 1, motorists experience progressively worse driving conditions as a road segment ages. 2, the rehabilitation or total reconstruction process can be very expensive. And 3, major reconstruction is disruptive to traffic flow, particularly a bad situation, especially in heavily congested areas. The proactive approach calls for keeping roads good rather than allowing them to fully deteriorate through their life cycle. The focus is on strategies that preserve and maintain existing good roads, extending their lifespan. A key to a successful pavement preservation is choosing the right treatment for the right road at the right time. The deterioration curve on the left says it all. The bottom of the scale represents roads where little to no preservation techniques have been applied. Roadways at the top of the scale remain in good condition throughout their life cycle. Beta's approach to pavement management planning consists of multiple stages. The first stage consists of developing a roadway inventory and inspection database to house the pavement management data sets. This sets the stage for field data collection, which comes next. Roadway inspections are conducted primarily using robotics automated technology, and as Stu previously mentioned, a cell phone is used to capture roadway imagery at 10-foot intervals. Roadway segments are then rated using a 1 to 5 rating, where a 1 represents a road in good condition and a 5 is a road in poor condition. As mentioned in the previous slide, the ratings are then converted by Beta to an industry standard roadway surface rating, or RSR, from 0 to 100, 0 being the worst condition and 100 represents a newly paved road. Reports and analyses are then developed based on the data collected in the field. The reports provide town officials with critical information pertaining to the existing condition of the roadway network. Repair recommendations are also included as part of the reporting and analysis phase. We also develop user-friendly dashboards that allow our clients to interact with not only their roadway data, but other infrastructure assets as well. Our dashboards have been developed through a culmination of collaborative efforts with our clients. We take a GIS-centric approach with everything we do, and we rely on feedback from our clients to make our dashboards the best experience possible. Joe will be showcasing our dashboard momentarily. Oftentimes, we are asked to develop capital improvement plans for our clients. This consists of generating a roadway repair priority list that can span up to 5 years. A backlog is established and recommended repair types are noted in the CIP for each year of the plan. We'll be going into more detail about our capital improvement plans later on in the presentation. And lastly, we also present at public meetings. These typically consist of explaining our pavement management methodology to residents, Board of Selectmen members, and mayors. So here are examples of roadway conditions with respect to their road surface ratings. These are examples of good roads. On the top, we have a brand new road, and given that it's new, a road surface rating of 100 was assigned to that road. On the bottom, we see a road that isn't in bad shape, but it's not new either. There are no surface distresses, but you can start to see that the asphalt is oxidizing. Over time, these roads will need some sort of treatment in order to keep them in good condition. Here we begin to see more distress symptoms as the road ages. These are what we call fair roads, where their RSR ranges between 50 and 75. The image on the top had multiple cracks which were sealed at one point. Therefore, the RSR is 74. On the bottom, we see a road that has not had any repairs and large amounts of cracks are present. This road is a great candidate for minor rehab. Moving along, we have our roads that are in poor condition. Textbook distresses that you can see here include potholes, alligator cracking, unevenness. These roads have reached a point where a major rehab or reclamation will need to take place. Again, these images are right out of the robotic software. And at public meetings, these images speak volumes. Up next, Stu will describe for us how the robotics assessments are carried out.
Thanks, Tito. Are you guys able to hear me still through my headset?
Yep.
Fantastic. I had to switch to another audio input. So the general process of how a robotics assessment will work, working with one of our partners, is that the first step that happens is the mapping. So part of the process that we do is creating a digital map to put the assessment data onto at the ending of an assessment. So first things first, the community itself will process a map and send it to Beta. Beta will process it and send it to robotics. And from there, we digitize it and do everything from creating routes for drivers to go through while they're collecting the data, as well as making a blueprint that the data will eventually be applied to whenever the assessment itself is finished for display purposes. Once all that is done, and particularly the routing is done, Beta will then go out and send techs out into the field to drive the roads themselves with the data collection equipment to pick up the images of the roadway for post-analysis. Once that driving is all done and robotics has confirmed that the full network has been collected and all the images are there that we need to proceed with the assessment, we'll then run all the images through our artificial intelligence models as well as quality control standards to actually provide the conditional ratings that we're going to be delivering to Beta at the end of the project. Once all the analysis and the quality control procedures are finished, we then put the assessment data up on our online platform called Roadway that I'll be showing you guys soon here, as well as delivering in the form of a shapefile and CSV so that the data can be further manipulated and analyzed by both Beta and the communities themselves once it's delivered. So this is going into the different levels of data analysis that you can get from robotics. So we already talked about the conditional ratings, those 1 to 5 ratings that Beta then transfers into the RSRs. But you can also go a little bit further. We've done a lot of product development over the last year or so. And you can now not only get the conditional rating of what the quality of the road is, but also individual distress identification that tells you what exact distresses are being picked up image by image and segment by segment. So instead of just telling you, this is a level 4 road or this is a level 5 road, we can say it is a level 4 road because of the amount of fatigue cracking, because of the amount of buckling, so on and so forth. Another aspect of the IDI technology is that it can also be used combined with the conditional ratings to produce a PCI conversion that we call HD PCI that's based on the ratings every 10 feet alongside the distress information along the segment, combined and weighted properly so that we can get you that 1 to 100 scale as well, 0 to 100. And then this is going into some of the benefits of the data usage of robotics and where it can benefit both our partners and the communities that we work with as well. One of the big ones is the flexibility that it provides. It means that you have less time in the field, less travel restrictions, less worry about when to stack projects up because you can get the data in and processing faster than you would have been able to otherwise. As well, another side of it is that it allows for pinpointing of visual inspection. Of course, there's only so much that you'll be able to see from roadway imagery. Sometimes you're going to need to take, cores. Sometimes you're going to need to go out and measure certain distresses and things like that. But by using robotics, it means that you're able to see the full network much more quickly than you would have otherwise and better pinpoint those more specific efforts afterwards. As well, another side of it is that retains the partner's presence in the field. So rather than, bringing in a van scan or, laser scanning and things like that, that kind of separate the different areas of a project from who's actually going out and interacting with the end client. It allows for data and the community to still directly interact and be on the ground seeing what the road condition looks like while they're collecting the robotics data. Another big aspect of robotics is that you get the image inventory alongside the conditional ratings. So you not only get to know what the quality of your roads are, but you also get 10-foot by 10-foot images showing you that as a kind of historical data of what your roads looked like at one point versus what they look like after they're maintained. This also can play a part in liability documentation, such as where potholes are, what damages there are on the outer edges of the images themselves, sidewalk imagery. There's a lot of different ways that it can be applied here. And then lastly, a benefit of robotics data, particularly the multiple deliverables that we offer, shapefiles along with the roadway platform, means that our information can be rolled into existing platforms, whether that's GIS or Esri platforms, whatever it is that you need, the data can also be imported into there as well.
Great, thanks, Stu. So our analyses are shared with our clients through our Manage My Roads platform, which includes our ArcGIS online-driven dashboards. PDF versions of our clients' planning reports and maps are also available through our pavement management portal. The dashboard allows municipalities to view and interact with their asset data sets, which can also include striping, curbs, and sidewalks. Beta provides training and support for all of our ArcGIS online-driven web maps, dashboards, and mapping applications. Up next, Stu will showcase a demo of the robotic software. Then we'll have a live demo of our dashboard and portal. Let me see if I can share my screen or actually give access to Stu so that he can share his screen.
All right, let me just pop in my screen share here. There we go. You guys able to see that on your end?
Yep, perfect.
Fantastic. So what we're looking at here is the data output from a recent assessment that we did with Beta Group in Lexington, Massachusetts. The reason that I'm showing you guys this one is it's because it's one of the assessments that we've done that has that level of IDI information applied to it that I was talking about before. So I'll really quickly show you guys some of the key aspects of the platform that you're able to use. I won't go into every detail just for the sake of time, but I'll show you some of the major aspects of it. So one of the main reasons that we created this platform was for the purpose of presentation and better communication around the quality of roadways. Something that we saw was that there was a lot of data being applied to some of these assessments that wasn't necessarily translatable. So we wanted to create a platform that you could more easily understand where the areas of your network are that need work and what areas are already doing well. So for example, you can see that all the different segments are color-coded by their rating, 1 being the best, 5 being the worst. So you can easily see, where you don't have to worry about, where it's starting to get worse, and where some of your major problem areas might be as well. Another aspect of this is that you can sort by the type of distress level that you're seeing as well. So say you don't want to see, where your already good areas are, you're able to pull them out and only look at the areas that you really need to. Another side of this is that what I was showing you there is the segment level. So this is a combination of all the ratings that are present along a certain section of road. But you can also go into the more granular point level and see each one of the 10-foot by 10-foot ratings that we've applied to the roadway as well. The main aspect of the point level, too, is that you can go in and actually pull up the imagery that's associated with the rating there as well. So, not only are you seeing what the quality of the road is, but this is where the image log comes into play, too. You can go in and look at the actual data that was provided to robotics that we then applied analysis to on the back end. So on this view, on the point level view, you not only get the image itself, but you also get a variety of metadata associated with it, such as the nearest address, the GPS coordinates, and particularly the time and date that the image was picked up. That comes into play, especially whenever you're talking about liability issues, when certain issues were picked up, when they were fixed, so on and so forth. As well, within the image by image view, this is where the individual distress identification comes into play. That image doesn't exactly work with it because it's in pretty pristine condition. But let's go to something a little bit worse. So for here, what you're seeing is that the patches and sealant area and the transverse and longitudinal cracking area are both coming up. That's because you have some sealed cracks and some sealed potholes, as well as regular cracking along the side as well. Really quickly, I'll jump into the segment level view too, and then I'll pass it back off so that the next part of the presentation can begin. On the segment level, what you're going to get is essentially an averaging out of all of the point level ratings along that segment. So from this stretch of Oakland Street, you're able to see what the average rating of all the 10-foot by 10-foot analysis is, as well as the full length of that segment and a percentage breakdown of the points that are present along there. But with the IDI level of information, you also get to see what the prevalence of each type of distress there is as well. So you're seeing, 2% of the road has fatigue cracking. There are 42 instances of patches and sealant, and in the end, you also get the combined HD PCI that's present on the segment as well. Then one last feature I'll show you guys that's part of the IDI level of analysis. One of the most important distresses that everybody in public works wants to know where they're seeing and how prevalent it is their potholes. So something that we added is this little show pothole indicator that whenever you pull it up, brings up a little signpost that indicates the location of every pothole within your network, so that you're more easily able to dispatch crews, see where your progress was from last year, all of that good information that's nice to have, especially whenever you're doing public communication about the quality of your road network. And with that, I will cut off my screen share and pass it back.
All right, excellent. Thanks, Stu. Okay, so I'm going to share my screen now, and we will take a look at our dashboard. Joe McGuire, it will be presenting that.
All right. Hi, everyone. Is everyone able to see the screen? All right, I'm seeing some people. Continue. So this is the Manage My Roads platform that we've developed here at Beta. This is utilizing the Esri's ArcGIS Online suite of applications. So one thing to note about this platform specifically, and Tito kind of touched upon it earlier in the presentation, is that this platform was designed and built based on a lot of the input we were getting from all the different communities that we work with throughout New England and also in Rhode Island specifically. So with that in mind, a lot of the things that you're seeing here, this is stuff that we felt were tools and things we could include in our dashboard that would support the communities just based on feedback we've been receiving over the years as we started to develop this dashboard. So to get started, I'm going to focus over on the top right-hand corner of the screen where the road network rating exists. This is specifically Smithfield, Rhode Island. So their overall network rating, is this the live?
There you go.
There you go. So the road network rating for Smithfield is a 66.20. And we note the last date that this was updated because we're always updating the site based on improvements from the town that we receive as feedback, and to make sure that we're keeping the database here at Beta up to date with the most current status of the roadway network. Below that, we have an indicator of the amount of road miles that were assessed for the community. So in this case, it was about 105 miles of road. And below that, we have a tool here, and it's a pie chart revolving around the repair category that we use here at Beta. So we categorize all of our roadways into 5 repair band categories, from major rehabilitation, minor rehabilitation, preventative maintenance, routine maintenance, and no maintenance required. These are the standard colors that we use. What's nice about this this widget is that it's totally interactive with the map. So this, again, similar to what Robotics was doing in their demo, we're able to highlight to you all the roads that fall within specific repair band categories throughout the network. And we can turn on multiple bands at a time so that it gives you guys an indication of what you're seeing in the town specifically. Also, it's worth noting that as you're adding to the total or clicking on different bands, the road miles indicator is also indicating how many miles fall within that specific repair band. Below that, we have web links, which bring us to different, a couple other portals that we have here at Beta that we provide the communities we work with. I'm going to go into those towards the end of the demo. It'll make more sense towards the end. Moving on, next to that, we have this roadway segments, and it's ranked by the CBV, or the cost benefit value of a roadway. This is something that we've developed as part of our pavement management program here at Beta. Basically, what this is indicating is that each road segment is given a value, and the greater the value, the higher up on the list it is going to fall for maybe, being looked at as a potential repair candidate. This is a tool that we've included to help towns kind of visualize the development of their capital improvement plan, or just their prioritization plan. Again, this is all interactive with the map itself, so you can simply click on the various segments and the map will zoom to those segments for you. And you can have multiple going at the same time. And this is to allow you to have the ability to see where these segments fall within the similar distance to one another. One thing to note at the bottom is that this is tabular, so we are able to show you each chains to the repair band category that it falls into. So we started with the major rehab candidates, then we move on to the minor, preventative, and routine. This is something that, again, we want towns and we want municipalities to be able to use this as a tool to help visualize developing their plan. And we've taken this into account as we develop this dashboard further. Moving on, next to that, we have our functional classification serial charts, and this is the backlog summary by the functional class. So your arterials, your collectors, your local roads, your dead ends, and cul-de-sacs. These are all broken out by the repair band category that your roadways fall within. And again, this is totally interactive, so we're able to highlight specific roads on the map that fall within these specific repair bands. This is something that we're always looking to improve on. So this is totally customizable for any town. It doesn't matter, what we're presenting here. It's what we want to do at Beta is make sure that we're providing you the most useful tool possible for your planning purposes. In the upper right left-hand corner is the map legend, and this goes through all the different layers that you're going to be able to see on the map as you zoom around. And next to that is this street list, which has every single street segment listed in alphabetical order on the map. One thing to note specifically with Smithfield is the reason we chose to demo their dashboard is the fact that they're a town that's done an extensive amount of work with us over the years, not only for pavement management, but also for various GIS layers and utilities in town. So the nice thing about our dashboard is this isn't only strictly used for pavement management. We're able to integrate all of the various utilities and other assets that a town might be concerned with, specifically curb ramps, signs, sidewalks, water systems, and we're able to integrate those so that you're able to see and view all of that data in one spot on the map so that you're able to understand with better regard as to what you have for assets throughout the town. Going back to the web links, we have our client portal site. So this site was developed to host all of the reports that Tito had kind of mentioned earlier in the presentation for the communities that we work with. It's also a snapshot in time to kind of give you guys an idea of what you're seeing for your road surface rating. Currently, baseline when we had initially done the inspections, when the inspections were carried out, the last time this site was updated, and as well as a quick snapshot of the total backlog for the roadway network. Beneath that is where we host all of the reports that Tito had mentioned earlier. And you can simply click on these, and these are all PDF reports that we're able to print out, or the communities are able to print out for their use. It's just a nice way to be able to have something to pull up in a meeting, since this is all hosted online and as a live website. So whenever you're in a meeting, you're in some sort of a presentation, this is a nice way to be able to come back in and utilize some of the information that we've provided to you as part of the pavement management program. So we'll go back to the actual dashboard itself. Below the client portal, we also have what we're calling our Pavement Resource Center. So the nice part about the Pavement Resource Center is that this is a way for communities to kind of get an idea of what types of repairs exist and are available to them to implement throughout their community. So we've developed this site over the years to try to cover most of the different types of repairs that are out there that we're seeing being utilized in the industry today. And each one of these are interactive, where you can simply click on a specific repair type and it will bring you to another page that goes through the description of the process, what type of roadway RSRs typically fall within these ranges, and the different the life expectancy, and then we also include videos of the actual process itself, just to provide a better idea of what actually is being done to the roadway given a specific repair type. And then finally, we just have the link to the beta homepage as well, where more information about the different assets that we cover are available. That concludes the demo of the Manage My Roads dashboard. So we can go back to the next stop. Tito, if you want to bring up the PowerPoint and speak to that too.
There you go.
So the point of this whole program, the pavement management program here at Beta, is so that we can help communities out with their budget and making sure that they're getting the most bang for their buck in terms of the allowances they have year to year for being able to implement roadway improvements. So this slide is showing specifically the type of budget analysis and forecasting models that we run here at Beta as a way to kind of show communities what type of a budget will have, what the allowance of a budget will have an effect on the RSR of the town itself or community. So for this example, we had a community that was at roughly a 70 for the RSR after we had conducted our round of inspections. They wanted us to run specific funding scenarios. The one with the italic scenario 1 happened to be what they originally were going to have for a budget at for the following year. And we were able to kind of show them what that might do over a 5-year period to the actual RSR. So we're always looking to at least show the community what they would need to maintain the current status of the roadway network itself. And this is just a powerful graphic to use with town meetings or in presentations to really get the point across that pavement is a huge investment for communities. So it's always worth taking a look at available funds and ways to utilize the money better in order to get the type of repairs you need to have some sort of an increase on your actual road surface rating. The pie chart that's there, that just shows you the different the different allowances we have for each type of repair. So this is kind of the standard balanced approach that we would take here at Beta, but we run multiple different scenarios depending on what type of community we're working with and what type of repairs they tend to use more than others. So this is all, again, customizable, and we're able to really dial in exactly how much the budget will have on the effect of the overall RSR. We'll go to the next slide. So going off of the analysis of the budget, I think maybe perhaps the main point of all of this is to get to a capital improvement plan development for a community so that they're able to implement this plan and really make sure that they're seeing the improvements they need in order to have their overall network in good standing. So as I mentioned earlier, we use the cost-benefit analysis approach in order to help us kind of develop the first draft of a CIP. The analysis for utilizing the cost-benefit value is just kind of a foundation or a starting point. It really helps us zero in on the roads that are going to bring the most value to the town or the community as a whole if they're able to conduct repairs. And this lends itself into us developing the actual capital improvement plan itself. We typically develop a plan, a rough draft, and we'll submit that to a community for their review and comment, because as we all know, it's not just what the data is showing, it's also, politics play a factor, and towns know their roads inside and out more so than even just sometimes the consultants do. We're just the ones here kind of giving you an idea of what we're observing out in the field. At the end of the day, the town and the DPWs themselves, they know what their roads conditions are like. So they might have other priorities that might not be exact to what we're seeing in the plan. And we're able to kind of balance that out with the development of the CIP so that it includes a balance between the cost benefit and value analysis and what the town really is trying to focus on themselves. And at the end of the day, the development of a successful CIP is the main goal, and that's what we're able to achieve through utilizing our pavement management program. So just kind of some concluding remarks. These kind of highlight the 3 pillars that we kind of base our pavement management program on here at Beta. So we always take a comprehensive inventory of the network. We establish the overall network rating, their condition, and the most effective way to prioritize the maintenance and repairs of a roadway network. We have designed our program to better manage limited dollars allocated to municipalities to conduct roadway improvements. And our program is capable of assessing the different types of repair strategies necessary to maximize the life cycle of the roadways that we're seeing across multiple municipalities in Rhode Island. And with that, that concludes the presentation.
Great, thank you, Joe. All right.
All right, we have a few questions that came through in the chat box. Stu, are you still there?
Yep, I'm still here.
Okay, we have one question from Jen, that for the dash cam that we use for robotics to take pictures of all the sections, how do you change that into the RSR? What are the cameras looking for, and does it include the bumpiness of the ride?
So first thing to go over is that it does not specifically include the bumpiness of the ride. The information that we're picking up is the visual imagery of the road itself. So there's been some study into usage of accelerometers within phones to pick up things like IRI, but generally it's going to require more, more advanced technology. And the purpose of our approach is to decrease the equipment requirements needed to conduct the pavement assessment. So the way that it works is that it's taking an imagery, and then essentially we have artificial intelligence models that have been trained to identify certain types of pavement distress. So whenever you create a machine vision model, you're creating a computer program that's designed to identify something within an image. So in this case, it might be a pothole. The way that you do that is by showing that same computer program marked images of potholes, indicating these are the patterns that are indicative of a pothole. This is what you're looking for. And you repeat that process up to millions of times if there is enough existing data sets to work off of. So essentially, a computer program is trained to identify the pixel by pixel patterns that are indicative of each one of these different types of distresses. And then after that training is done, and after the quality control procedures are set in place, it's then able to independently identify all those different types of distresses and compound them into a single conditional rating.
Thanks, Stu. Yeah, and it's important to note that what we're trying to provide to municipalities is the rating of the road as what you would need to put together a capital improvement plan or a maintenance plan for the preservation of the road. So whether that crack has a bump associated with it or is just a flat crack, to correct that problem in the road or the stress in the road is still going to use the same projects that you would have in a normal CIP program. We have one more question from Jen too, is how does a municipality usually engage with beta? Or are we just presenting on the same topic? I think it's important to note that beta and robotics have teamed together to do these type of projects for a multitude of different municipalities in Rhode Island and all throughout New England. And we've done a lot of projects now, but Tito, if you want to talk about our relationship with robotics and how we put those projects together.
Absolutely. So the majority of towns that come to us by word of mouth. A neighboring town will say, hey, Beta Group has this really great program, and they're utilizing robotics technology to collect the data. So the majority of clients that we receive are by word of mouth, but then there's also clients that we interact with through conferences such as this one, and a multitude of other marketing formalities and practices that we do to gain clients as well. But typically a client would come to us, we'd show them our platform, we show them what robotics would do or what they can do, and then we go there. That's the majority of the clients that we get.
One question that I had is, Stu, if you could talk about how this differs from other pavement management programs. I know that Beta, us personally, have been in the GIS and pavement management realm for a really long time now and have generally used people going out into the field. And I know you talked about that a little bit in your presentation of how this differs from a person going out. But how have you seen data compared to the way that it was traditionally done and the new way that we're doing it now?
Yeah, absolutely. So one of the big aspects that we kind of we're trying to overcome early in our company's life was trying to remove any aspect of subjectivity from ratings. Something that we would see working with municipalities was that it would be very difficult to repeat rating standards year over year. Inspectors might change, they might be working with a new consultant, or in some cases, especially with municipalities that handle a lot of this work in-house, they might have somebody that retired that used to do all their pavement assessment and things like that. So being able to give a more technological backed baseline to the conditional ratings of a roadway instead of relying on human eyes to kind of do that work, both kind of laid that groundwork, and then also realizing from there the kind of scalability of it. Whenever you're using human raters, you're limited by the time allocation that they may have, the geography of where they may be located. You only have so many assessors that can go out at a certain time. So there's limitations to when that work can be done and when that information can come in. So by using a easy to access technological approach, it means that you can focus the efforts of the people that might be out assessing the roads instead in the post analysis and in the decision making around that data, rather than spending a lot of time collecting it itself.
I know that you guys do a lot of work on roadway ratings and things like that, but what are some other things that you guys have seen that clients want to add into their CIP programs, or do they have other CIP programs? I know a lot of directors are, not only managing roads, they're managing sidewalks, signs, other things like that. And what kind of programs do we put together for those type of assets?
Yeah, so something important to point out here is that robotics only encapsulates a limited aspect within a capital improvement plan. So in a lot of ways, we're reliant on the engineering expertise of our partners like Beta to take the data that we are able to create and then work with it. So within the area of other assets, especially within the realm of machine vision and artificial intelligence, it's always going to be an area of much interest and a lot of product development, because if a computer program is able to identify a pothole, then it can also identify a sign. Of course, there's a lot of lag time between those things, and the more time that you take developing one side of the technology, that means that it's going to take longer to develop other sides of it. But like you were saying, those are all pretty much roads, and then things that are adjacent to roads are all of very high interest to a company like Robotics, because as soon as you do the roads, then it's okay, how do we use this technology and apply it to our sidewalks to make that more efficient? How do we maintain our road furniture and things like that, our fire hydrants and our signage and our bus stops? And those are all things that are potentially possible with machine vision technology. So I completely agree. Those are all kind of areas that we're exploring and looking into how we can help out the industry in that way.
Yeah, I know we've had a few projects where we've taken the photos from Robotics that are, the same photos that you use to look at the road and the condition of the road, but we've also used them to, as an updated Google Street View to see where there are signs and use that and collected it separately. Although it's not using machine learning, but just having those pictures in the first place is a good way to get started on some of those other assets. So once we have like the machine learning and everything too, Tito, if you could talk about how we QA/QC the data. So it's great that we're using the dash cams and everything to pick up the data, but how do we make sure that it's reliable so that when that town engineer or DPW director is going to council to use the data that we collected objectively, how do we make sure that is is the right data that it should be using and is reliable?
Yeah, so we basically do a thorough QA of all the data sets that come in through robotics. So every single image that's given to us, we then make sure that the rating that was on that image is correct. So we then obviously take those ratings and transfer it over, convert it over to our industry standard 0 to 100 scale. But we want to make sure that what we're seeing out in the road is the exact, the correct distress that's being implemented in the plan. Beyond that, prior to any robotics data collection or assessments, we also do a thorough check on the GIS files that we get for the centerline roads. And then also if the town gives us any pertinent information as far as sidewalks goes or anything like that, we also want to make sure that that data set in GIS is ready to go for us to incorporate into any plan. So yeah, QA is huge for us. We want to make sure that at the end of the day, the client is getting exactly what they're requesting.
To go off of that too, typically what we have is legacy data from towns or communities, and we're able to kind of compare, what we were seeing either the last time or what the town kind of had for older, roadway statuses for their community, and we're able to kind of compare that to what the robotics data was picking up to make sure that things, roads that are known to be in bad condition are not somehow, being rated a little bit better than they should. And we also have, our field crews go out and audit a certain percentage of the roadways to go out and just get some eyes on it still to visually confirm that what we're seeing is consistent across the network.
Yeah, and roadway repair history is very critical as well. So any new repairs that the town has done, even after the robotics data collection, it's important to get that information so that we're correctly reflecting that in the plan.
All right, two more questions. One for Stu is, what have you guys seen with data as far as timing of doing inspections? What's the best time to do inspections? Has the window gotten bigger now that we're using machine learning, or what should towns be looking to? When should they be looking to inspect their roads?
Yeah, so the timing window, a lot of the same kind of restrictions apply, because in the end it is kind of a more technologically based visual inspection. It's using a machine to kind of substitute for human eyes. So things like weather are always it's a requirement for doing the inspection. You can't do a visual inspection whenever it's raining. Similarly, you can't collect robotics data while it's raining. Snow on the roads, things of that nature. So usually we see, peak collection times being around the, late spring to fall range. But, we have seen collections be done in the winter. You get a couple of clear days and you're able to go out and drive a large portion of a network just within that time. So the kind of yearly window is similar, but in a lot of ways, whenever you do have those, it accentuates some of the benefits of the technology, and that, where previously you may have had to plan out, months ahead or weeks ahead of when you would be able to allocate the time to go out to these towns and do the visual inspection. Now you're able to, strap a camera in the car and pick up as much information as you can in a couple of days in what might have taken a couple of weeks before.
Yeah, and I would assume you're getting just as good as data as, that person who has 15 years of experience rating roads is one person who would normally spend, like you said, 2 or 3 weeks in a town driving every road and looking at everything, taking that experience and applying it to multiple locations all at once in a shorter time period and getting the same quality of results. Another question that kind of goes along with Jen's question here too is how often should you be updating the data, and what happens to it once we collect the data? Where is that data maintained, and who maintains it? Does robotics, does Beta maintain it? And how often should we be doing re-inspections?
Sure, so that's twofold. Robotics obviously goes out and when we go out, we'll do the field data collection. That information on the phone gets uploaded to robotics cloud. and that's where all of the images are maintained on their end. Once they go through the AI and analyze every single image, they'll send us the imagery along with an updated shapefile, point shapefile, which has a link to each and every single image. We then grab that point shapefile and we push it up to our ArcGIS Online dashboard so that the client can also go in, click on the point, and then that representative image of that section of road will show up. So it's twofold. We have the data sets on our end so that the clients can view it on our dashboard, and then robotics also has the imagery on their end, which they can illustrate in their roadways platform. If you want, at the end of the day, if you want your imagery, you can have it.
To go off of the other part of the question too, in terms of like how often do you want to update your roadway inspections and everything, and typically, you know, we see communities and we kind of recommend that you consider doing some form of an inspection process every 3 to 5 years. That way you're keeping your status of the network up to date. We also provide support to the communities we work with, you know, over the years through different types of support service contracts and stuff where, you know, we can have the roadway improvements from a previous year provided to us and make those updates in the database and make sure that those are coming through on the dashboard themselves so that, again, communities are always looking at the most current data sets that they have.
All right, great. If there's no other questions at this time, I think we're done. So good job, guys, presenting. And if anybody has any questions after, you can always send it through the SL Events portal, or our contact information is linked in with the session notes and everything. So thanks a lot, guys.
Great, thank you.
Thank you, guys.